Anybody willing to take minutes for us later, or a group of people willing to take minutes? We're going to have an awkward silence until somebody says yes. Should probably get started. Huh? It's 1 o'clock. All right. Let's get started. Welcome to the Deepspace BOF. Probably some people will still going to trickle in from lunch, but we have a pretty full agenda, and I expect at least somewhat of a discussion at the end, so it would be nice to have enough time for that. I'm Lars Eggert, this is Alvaro Retana, we're the MCs for this session. It's a BOF in the IETF, meaning it's a group where we are going to debate whether the IETF should charter a working group in this space. And what this space means will be the topic of the next couple of minutes and a couple of presentations. Next slide, or can I do it too? Note well, oh yeah. It's Thursday, so this slide is not new. However, we might have some people who are not new, who are new to the IETF and the processes. So this is a reminder of the policies that are in effect at this meeting and throughout the week. There's a lot of text on this slide. Please read it. Specifically, also, please read the document called BCP 79 carefully, which outlines the most important bits here. By participating in this room and also in the IETF in general, you agree to follow our processes and policies. One important policy is that on IPR. If you are making a contribution to the IETF, and that includes speaking in a meeting such as this at a microphone or sending email to a mailing list, and you know that there's any IPR that's associated with your contribution, you must disclose this fact to the IETF, and there's a form for it. And if you hear a contribution being made and you are aware that there's somebody else holding IPR, you can disclose that fact to the IETF. And if you cannot follow that policy, then you must not participate, i.e. don't go to mic and don't send email. We're gonna record you. We're gonna have written recordings and audiovisual recordings of the meeting, and they're gonna be made public. So that is a notification to you that's gonna happen. And you also agree to work respectfully with other participants. So let's keep the discussion technical and on the technical details and not personal. And there's a lot more documents that you can refer to there at the bottom in case you get bored during the meeting and need something to read. It's exciting. I have control over here too. Oh yeah, here. Right. This is the awkward silence slide. Do we have somebody or multiple somebodies who would be willing to take notes for us?
Yeah, I've just posted it into the note taker. I'd be happy to take notes.
Thank you, Gori. The note taker app being the one linked from the data tracker. So if you want to help out Gori, who is holding the pen, multiple people can edit this document at the same time. So please, correct names, or Gori doesn't know everybody, so that he will put question marks when he doesn't know the name. If you know the name, you can fill that in and save him and us a lot of time later. And you can also clarify and correct statements throughout the session. Thank you, Gori, and others helping him. We're going to try and keep an eye on the chat room. If there's somebody in the audience who would volunteer to sort of go to the microphone, if you see something that's raised in the chat room that should be brought to the group's attention, please do so. Do we have somebody who would be willing to do that? Thank you. And it worked even without any awkward silences, so that's already a good sign. We have an agenda. We're in the introduction part. We were followed by, we have 4 presentations on use cases and problem statements from various space-related agencies and individuals. We're going to go through them. We're going to do 10-minute presentation followed by 5 minutes for clarification questions on each of those 4 presentations. We're going to take a look at the charter text. I sent it to the mailing list a couple of days ago, and there's already been some feedback that was raised. So we're going to show you the same text that was sent to the mailing list and ask for, again, any clarification questions or quick suggestions on improvement. And then we have a pretty lengthy slot afterwards for discussion. And if all goes well, i.e. we feel like we, the chairs, feel that there's any point in asking whether a group should be formed, there's going to be a few hums at the end. So especially if you're remote, and I understand there's a space-related standards meeting going on simultaneously where people might be like sharing a screen. If you want to individually participate in the polls later on, you should individually log on to MeetEcho and the IETF tool so that you can later on then put your ballot in according to what you think should happen to the work. Otherwise, we just get like one vote from London, which would be, probably undercounting interest a little bit in some cases. But you still have a lot of time to do that, so you can do that on the side. Right, any agenda bashing, anything I forgot, Alvaro?
No.
Okay, great. Right, quick words, since this is sort of a topic that's on the intersection between sort of the space community and the IETF, and those of you who are not IETF regulars might be a little hazy on what kind of meeting this is. So the IETF has a process by which we start new work in a working group, and that's called a birds of a feather session, or a BOF, which is what this meeting is. Before we got here, a BOF proposal needed to be submitted to the steering group, and it was reviewed and tuned, and an area director has sort of approved to hold this meeting here. We are now at this BOF session. The point of the BOF session is to present the problem and the proposed scope of work to the community and get feedback on whether we should do it, basically. And after the BOF, it goes back to the area director and the ISG to figure out whether they heard enough support for the work to actually do it. So the possible outcomes is, we go straight to working group. Maybe if there's some open issues that we can't resolve on a mailing list, we're going to have another BOF. Or maybe, the topic dies and will never return, but that's somewhat unlikely. Typically, things come back in some shape or form. And the key part here is to inform the area director and the ISG. So the feedback in this room is incredibly important so that the area director knows, this is what the community thinks about this particular scope of work. Right. This is the Deepspace BOF. And it's a misnomer, as has been. It's a catchy kind of title, right? And it's a sort of the implications are nice, but the work that we're going to see presented is not really for deep space. There's use cases for lunar networking. There's an interest in extending that same sort of work towards Mars and maybe sort of beyond. But at least sort of in my layman's understanding, like deep space is sort of far out there, which is why I had like the galaxies on the intro slide. So it's space related, but probably actually not deep space. So we're gonna come up with a different name for the working group if we decide we're gonna have a working group. That way we don't have to have that discussion now, because I'm sure you all have great suggestions for what the name could be. That can wait until we know that we need a name for something, right? So let's not have that discussion now. But the topic of the BOF and also the topic of the proposed work is basically what I would call like IP-based space networking, with a particular use cases in mind that are maybe more near Earth than deep spaces. It complements, or the scope of work, at least in the minds of the proponents, complements the work that has been going on and is going on in parallel in DTN, which has the bundle protocol, which is a stack for space that has been developed here in the IETF and is in use. This is IP-based networking, which the bundle protocol is not. So at least sort of, again, in our layman's mind, this is sort of a complement that has some slightly different properties that might make it more attractive or less attractive. But it's not like a replacement or something like that to the DTN bundle protocol. And I mentioned initial deployments are specifically lunar networking. We have a few presentations on that. The idea is that the work that would be done is at least conceptually able to support communication towards Mars and maybe something along those distances. but maybe not like to talk to Voyager or something like that. The working group is, we do want to keep those sort of deeper space aspects in mind as we do the work, if we do the work, so that the architecture has support for them, so we don't need to do like another new architecture when we move away from lunar deeper out there. So that's like the chair's attempt at sort of paraphrasing what the scope is. And you're going to hear a lot more details from the various presenters. I should say all of them they come from different agencies, from different organizations. They have slightly different viewpoints. There's a lot of overlap there, but there's also, disagreement is too strong a word, but maybe different emphases on different aspects of this, which is sort of natural when people come together and try to find common ground for something in the IETF. I would suggest we sort of focus on the overlap and not sort of on the differences very much. Right, there have been a number of side meetings. There even has been one earlier in the week. I guess the intent would be that if there's a working group, that there wouldn't be any more side meetings, just to not confuse the community about what's going on and what is this meeting about. Specifically, it wouldn't be a meeting that had the same name as the working group. That would be my charter out of this. There's also discussion in the IRTF, which is the IETF's research arm, to start a quote-unquote space research group. So some of the topics that have been discussed in the Deepspace side meetings might actually be fully in scope for that space research group if we know, when we know what scope it has. I think, is Eric Klein here somewhere? So Eric has his hand up over there. He is like holding the pen for the proposed charter of that research group. So if that's of interest to you, that there's a person to talk to. It's not officially chartered yet, but it's under discussion in the IRTF. Right, and with that we go to our 4 presentations. Do you have any questions up until now? Excellent. Who is first? Was it Wes? Okay. Hi, Wes. Go ahead. You have 10 minutes, and if we can figure out how to set the timer, you'll even see it ticking down. Please go ahead.
Okay, great. I take it you can hear me.
We can.
Okay. All right. So, hello. A lot of you know me because I've been working in the IETF for a couple of decades. I've also been working on networking in space for a couple of decades. And what I have today is actually to correct something Lars is, not representing any agency, just like everyone else participating as an individual in the IETF, but have a lot of informational references to share on places IP is showing up related to lunar networking in the near future and in present development activities. And I think you'll find it pretty interesting and excited. It's a little different than things we normally talk about at the IETF. I encourage people to pull up the charts locally because I have a lot of hyperlinks, so you can go read these things I'm talking about yourself if you don't believe me. So go to the next chart, or can I control it?
You have control, yes.
Perfect. Okay, so we've already beat it to death. I think the moon is not deep space, but I wanted to be more clear about the relative latency. So one-way delays, you could expect to be about 1,300 milliseconds. And that's an interesting number actually to some of us, because you might remember the buffer bloat measurements people have shared maybe 10 years ago. There were cable modems with that much latency in their queues. And so we actually have for a long time a sort of weird existence proof that some internet protocols at least do work with lunar delays in the path. Of course, they don't work well, but some of them can continue to work even with long delays. So I think one of the things that we should be looking at in this BOF is making IP protocols work better with long delays. And disconnections are another aspect that I think can be factored out and considered separately. And I'll show you why. So as some background, most people I think know, because it's been talked a lot in number of web pages and other media articles, but IP networks are used on board space vehicles a lot now. And what you might not know is they're being planned to be deployed in various lunar missions. So in orbiters around the moon, in lunar habitats and rovers on the surface of the moon, and also now spanning the links between the Earth and the moon. And of course, as we've said already, the DTN bundle protocol is also there and an important part of overall network architecture. So this is all sort of supplementary to that. To give you a sense of what the network stack looks like from the perspective of a user mission application at the top of this diagram, there are different ways of sending and receiving data. And on the right-hand side, going directly into lower level protocols, even at the link layer, is a way things have been done a lot in the past. As missions are more complex, now the things more like the DTN bundle protocol on the left-hand side are becoming important so that we can scale the networks up and support routing. Of course, today we're talking about the thing I've highlighted in the middle, which is an IP-based transport stack to provide an alternative for applications where that makes sense. And then, of course, this will allow you to use normal IP-based applications like we already have a lot of in the internet. It's important, though, to understand there's no like magic bullet network protocol stack here. There's a number of options. Different missions and even applications within missions are driven to do different things depending on their needs. And so these things actually all coexist on the same link layers. So one of the places where IP is showing up is in specifications related to networking and communications for this Lunar Gateway system, which is a moon orbiting space station. And there's a document called the ICSIS, which I mentioned I have hyperlinks. You can find this yourself. It's pretty long. A lot of it's on the physical and link layer kinds of details. But the protocol stack diagram I've got on the bottom left here, it shows circled in red where IP shows up. And it's clear you've got sort of instead of the single bottleneck in the hourglass that we're used to in a protocol stack for the internet, you have sort of dual necks in the hourglass with bundle protocol and IP. And IP is importantly getting used not just as an underlay for bundle protocol, but it's present for applications to use with normal transport protocols directly. So additionally, there are relay systems being built, and one of them is called Elkhorns. The link at the bottom takes you to the webpage for the Elkhorns project. I just wanted to highlight that, so adding relay satellites around the moon, it will increase the availability, visibility, and access to higher data rates underlined on this chart for users on the lunar surface, potentially making a situation that's more internet-like for lunar users. And this chart may be hard to read unless you grab a local copy, but this is, again, from a link you can find online, showing that there's a multiplicity of different network providers that will be supporting access to the moon. The Elkhorns relays I just mentioned are second from the right. There will be other international relay systems furthest on the right, and there's also a number of different direct links that will be provided by different agencies. And some of these are provided and operated by commercial companies as commercial services, which is a new, interesting, and exciting thing that I think should be important for this BOF to consider, because we're not just talking about like stovepiped systems run by single agencies anymore. It's starting to become a multiple provider and increasingly networked system. The LunaNet architecture actually is something that you can, again, follow the link on the chart to learn more about. It was created by NASA, and the European and Japanese space agencies are partners as well at the moment. And it will enable internet-like data and GPS-like services for users at the moon. It includes internet protocol within what's called the LunaNet interoperability specification. And I've highlighted that in yellow, but important to point out, it exists alongside both frame layer services and DTN services. So just like I was saying, there's no one size fits all networking solution at the moment for these users. The LunaNet specs enable there to be multiple LunaNet service providers, or LNSPs, and enable users to be able to interoperate with a number of different LNSPs. It can increase coverage opportunities, and it can actually enable, in the long term, user-to-user networking across different providers in a more internet-like way of doing business in space. I don't want to talk too much about routing, but that's one thing most people immediately want to talk about. That initially, because of a small size of a network, could be just like time varying static routes. And because LNSPs could be commercially owned and commercially operated, there have to be some coordination aspects between them, just like in the internet, that need to be worked out. And so last chart, my view for the role for the IETF here is to supplement what other groups are already doing. Specs I provided references to, those exist, and they reference IETF documents. Anything the IETF can do that makes IP perform better and that makes IP transport perform better, it'll be useful to mission users, and it will be useful to operators of these kinds of lunar networks. And 10 minutes is up.
Has been up. Thank you, Wes. That was very good timekeeping there. We have time for some clarification questions on Wes's presentation. I see Stefan in the queue. If somebody else would like to ask a question, please get into the queue using the Meet Echo on-site tool. Thank you. Stefan? Dropped, so Alberto.
Oh, thank you. And hey, Wes, nice seeing you. Thanks for the presentation. My question is, how much commonality in terms of the problems and requirements you find between, this specific charter IP for space with the existing DTN working group?
Oh, I think that it's a separate topic entirely, because if I'm able to scoot back to this chart, I'm looking at it from the viewpoint of applications. So if I have an application that's IP based at the moment, and there's a lot of inertia in existing code, it's not easy to just say adopt a different protocol stack entirely. So the work, as I view it, that might happen here is to improve performance and enable greater use of IP-based applications.
Okay, thank you.
Any other questions for Wes? Okay, let's go to the next presentation, which is being shared. Takami-san, it's your presentation. Are you there?
Okay. Hello,
Please.
I'm okay, so I'm Takami from KDI Research. So,
You don't need to share slides. We're already sharing them.
okay,
You
sorry.
can control them with, I think, your own.
Okay, thank you. Okay. Okay, so first I will talk about the background of our company. So I think I changed the next slide, but so.
There's an arrow at the bottom that you can.
Yeah, I prefer go to the next page program, but so. Sorry. Oops, sorry, I missed. Could you share them?
Would you like to share your own slides, or?
Oh yeah, no. Please. Sorry, I missed it.
No problem. We'll bring them back, and then you can control
okay.
them with the buttons on the bottom of the screen,
Okay.
on the bottom of your screen.
Okay. Okay. So, our we KDDI, a Japanese telecommunications company. So, our roots lies in the international telecommunication, and we provide not only terrestrial service such as mobile phone and fixed network, but also satellite communication service. And so now we are planning to establish a direct communication between the moon and Earth, and mobile communication on the mobile communication like a 5G network on the lunar surface. And today I talk about that our plan to the our feasible study of the lunar surface networks. So we just started the feasibility study for the this future started on the lunar mobile communications. So we assume the IP-based network such as Wi-Fi or several network will be established on the lunar surface due to their easy to develop some terminal applications or consistency with Earth to Moon communication and stability. And so we currently think of two key considerations are essential when considering such a network. One is a network operations maintenance on the moon. So it is difficult to go to the moon when some trouble is occurred. Because very long distance between the Earth and the moon. So and then we need to some operator maintenance remotely from the Earth, or we need to some collaboration with some local staff and Earth remote staff. So how to operate or maintenance on the such network is one issue, essential issue. The second one is ensuring the interoperability between the lunar and terrestrial the moon and Earth. So there is many networks. So I think this figure is so. So there is some currently between the lunar and moon and Earth is uses some direct communications, and so natural JAXA plan to build some DTN-based network between the Earth or and Moon. And so from the on the the lunar surface, we assumed some operator will build some network on the lunar surface. In this case, also there's many networks on the lunar surface or between the Earth and moon, and then how to interoperability such networks is one issue. Another issue is such to build the networks. So this is the last slide. So finally, what we discuss about the our areas of interest. So first, is the routing and address scheme. So as I said, interoperability is one item to discuss about such a situation, and so routing protocol or is one issue of the such to build such a network. So of course, the program is a link breakout or some communication down with occur frequency and how to advertise such right route or distance is one issue is I think, and so addressing system also needs a consideration. So because who assigned the IP address on the lunar surface, or some who manages such address, or some what would be the moon's top level domain or something. I think this is a potential of two discussions. So second one is a transport protocol. Of course, so I think so when many people or the agent go to the moon, and there are many huge number of sessions will be established between the Earth and moon. In this case, we need some condition control or flow control. But so current end-to-end based on condition control or flow control is maybe do well. And then we use some ECN or some mechanism. And so, as I said, so between the lunar and Earth, and some predictable disconnection is occurs. So how to know the some transport protocol knows such situation or timing is a program. I think such a discussion items. I think. And so third one is the application protocol. And so of course, and this is also same program as a transport protocol. And so application protocol has some timer or some flow control mechanism, or like some dash protocol or something. So adaptive rate or something. So we've seen discussing some such situation. And last one is the clock synchronization. So now NASA is developing lunar time standard. So I don't know such time scale synchronization is currently we does not discuss well yet. But so I think this is also one study item. I think so. That's also, I think there's many, still much of explore about the networks addressing. There is challenges critical for the extending the internet's coverage in the future. I think that's all. Thank you.
Thank you very much. We have some time for clarification questions for this presentation. I don't see anybody joining the queue. Zahed?
I'd phrased it wrong, but anyway, I'll ask the question. So, so do you have like any kind of like place where I can go and see like what are the things that you actually want from transport protocol that is already there, it's not working? Because I see like a lot of things that, at least 3 things that's very core to transport protocol. Do you have any place where I can read more about it?
So currently on the simulation, I think TCP or Quick will do well, but so it is sorry. So we sorry. So what to say? So we try to check some behavior of the transport protocol between the moon and Earth. And so I think even if there is some 10-second RTT, so this protocol do well, but so it is difficult to the high performance and on the such long RTT establishment. And so I think I feel there is some congestion control mechanism of protocol is changed for the such.
So you mean like there are some assumptions like, okay, with the current internet, all these things would need to be testified again higher and longer RTT and BDP and all that.
Yes.
So it's kind of like we don't know. We are expecting things to happen there, things to be needed there. Is that the right conclusion? Because this is an important question, because we're in a working group forming BOF, and I would like to know exactly what are the problems.
I would ask you to keep that question for the follow-on discussion, because it's not really specific to this discussion. I think Mark will have a presentation that covers some of these things.
Okay.
And then also the charter text makes it a little bit clearer about what is in scope.
Okay,
thank you. Any other questions on this presentation? Okay, then let's go to the next speaker.
Thank you.
Alvaro was pulling up the slides. We will share them. You should see 2 buttons on your screen that you can use to move the slides forward and back. Please go ahead.
Okay. Hi, everyone. Can you hear me?
Yes.
Okay. I'm from Beijing Institute of Spacecraft System Engineering, which is in charge of designing a lot of spacecrafts in China. I'm also the CCDS SOS Deputy Area Director. Let me see. I can't control the slide.
Yes, you can with the arrows.
Oh, yeah. Okay, I see that. Okay. It's just a little delay. First, I give some background requirements. In China, in deep space exploration, the Chang'e 4 has already landed on the far side of the moon. And we have Chang'e 6 returned with soil from the far side of the moon also this year. And the Tianwen-1 with the Mars accomplished surrounding landing and touring with 1 mission. And also in the coming year, China will continue to carry out lunar exploration projects such as the high precision lunar polar region landing, and also construction of international lunar research station. And we will also carry out the planetary exploration projects such like the mission to stamp and return from the Mars. And also before 2030, China will achieve a manned landing on the moon. And in the long term, we will further promote the development of new industries. And to support these missions above that I present, we will need communication, navigation, remote sensing constellation around the moon in the future, which will provide efficient network communication, precise PNT, and also efficient space awareness and on-demand information services. And for current research status, we know that the protocol architecture is a key to support this build of this constellation. So first, we will to analyze some of the organizations to make the standard for these communication protocols. First, for the CCIDS, we can see that it already had a space communication protocol architecture, which is shown on the left. It has 5 layers. But in 2023, there are another architecture, which you can see that the layering is not that that specific. It only has a data linking layer and a physical layer, and all the above is just called upper layers. And also for the onboard communication, you can see that in CCID SWAS area, it has a 4-layer architecture, which you can see that the transport layer is not defined specifically. And also, we know that for ECSS, it also has defined a lot of standards, which can consist of the communication standards and other standards. And for IETF, it already has developed the TCP/IP product architecture and also BPLTP. And to summarize that, the network development trend is to build interconnected Earth-Moon integrated networks to support the further exploration of the Moon and also the deep space. But the current product architecture, you can see that it has different layering and also has different protocols and also different applications. And for our team, we have several key achievements, which include the protocol architecture and also simulations and for the network and the emulation system. And also we have developed a flat software architecture to support the product architecture. And also we have developed the network core hardware products. This is the protocol architecture that we developed. You can see that we have integrated the CCSDS and also some of the ECSS protocols and the IETF protocols. From the top to the bottom, we have 4 layers: application, transport, network, and all the layers below network layer, we call it sub-network layer. And you can see that for the sub-network layer, we have left is to support the space communication, and for the right is to support onboard communication. And you can also see that we have BP, CFDP, and also LTP and the TCP/IP in the in the protocol architecture. And in order to analyze the protocol performance in different scenarios, we have developed a network simulation and evaluation system in order to enhance the protocol system design and verification capabilities with support of Nanjing University and also Xiting University. And sorry. And also we have developed a software architecture. We call it Fuxi. You can see that we have a lot of supported products, which including the CCIDS such as telecommand, advanced operating system, and the unified space link protocols, and also the ECSS packet utilization standards protocol. And also we have developed some protocol support, the CFDP, BPLTP, and also MS. And also we have developed some component support, the DT and the TSN protocols. And this shows the relationship between the Fuxi software architecture to the protocol architecture. You can see that all of these protocols have been developed by the software components, which you can see is inside the middleware layer. You can see that we have supported the POS, MTS, and also the transport space packet protocols, and with the support of system operation layers and the hardware layer. in order to run all this software architecture and to support the product architecture, we have also developed the space router and the TD switch, which will significant improve the communication network capability of the system. You can see that we have the system and network management unit, and also the onboard TSN switch, and also the space network protocol router. So with the support of this product architecture, software architecture, and the hardware products, we can have a lot of expected application effect. For example, we can support the grant application to simplify the operation and has automatic upload ability. And also, it can has less cross-storming information sharing between different spacecrafts, and we can have the plug and play ability, and also intelligent autonomous management. And in the future, we also have a prospect to build a constellation around the moon, and also which can be expanded to the deep space, which we call it Chao. And this is to have a Earth network which will be connected to the lunar network, which is on orbit, and also the lunar surface. And in the future, it can extend to the deep space. For example, we can connect this network to the Venus network and also to the Mars network. So this is the whole presentation. Thank you for your attention.
Thank you very much, and also thank you very much for sticking on time. This is great. And I also want to thank the previous speakers. Sometimes these remote presentations are very difficult to do because of time zones. So thank you very much, also Tagawi-san, for making time for us at whatever time of the day it is for you. Right, we have a couple minutes for clarification questions for this presentation. And Greg is in the queue, and there's some questions if you're actually in the queue or pressed the wrong button, but you're standing there, so I assume you are.
Yes, thank you. Greg Mirsky Erickson. So I'm interested, so you mentioned that you envision that this network will be a heterogeneous network. So would you think that their nodes will be of different capabilities, different different, in what regard they will be not homogeneous?
Sorry, your question is which slide?
Yeah, in the introduction, so you characterize this network as a heterogeneous network. So which means that there is some differences between systems that communicate.
Yeah, I see that because currently the different domain has different product architecture. So they all have their own product. Some not standard. So we need to connect these different aerial spacecraft into one network. So they have a lot of varieties that we need to, like some of them maybe need to the protocol translation. And also we will, because we have the Earth network to connect to the Moon network. So the time delay, and also they are different, have different architecture. So we need to solve this problem.
Okay, thank you.
Thanks, Gori.
So, Gori Fairhurst, thanks for your talk. I see IP appearing and TCP appearing. You don't mention IPv6 versus IPv4, or whether you're interested in other transports apart from TCP. So how heterogeneous at the IP layer do you expect this to be?
First, because for the ground network, we all use IP, and now it's translation from the IP version 4 to IP version 6. So in order to connect the Earth network and also the Moon network to the ground network, so we have the IP as the key network layer protocol. So you don't need to do any protocol translation, because we all use IP for the network layer. But for some scenarios that in Deepspace, the current TCP protocol may not work very well. So in In this case, we may need to have like LTP protocol, but we can put it on top of IP protocol, so it can be used together with IP and also UDP. So this is what we still think the IP may be the key network protocol.
Okay, thanks for clarification.
Okay, Abdul Salam.
Yes, thank you. I've seen from your presentation that you have some evaluation or already architecture model software to evaluate. Do you have any comments on the results? What are the results? Testing, I mean the testing results of the performance of your model.
Okay. Currently, we and also Nanjing University, we have done some results on the comparison. But here we can see that for the deep space, we can see that the LTP can be used and the performance is better than the TCP. And now we have also deployed this whole soft architecture on board the Churchill 2, which is the lunar orbiting relay satellite. But the test is still to be done in the future because it will need the support of the ground station, and we expect that to be tested on board next year. But now it's already on board the spacecraft. I think maybe next year we can give the real performance to you. Thank you.
Thank you. And we close the queue and we'll go to the last of the initial presentations, which is being given by Marc Panchet. Go ahead, Marc.
Okay, good afternoon, evening, morning, or good night, depending on where you are. So this is kind of a summarizing bit of the use case and then proposing some bits of an architecture. Okay, it should work. Can you do it for me? Yeah. Okay. As you have seen in previous presentation, essentially on celestial bodies, and I'm using celestial bodies being Moon, Mars, or others. For both surface and orbits, we'll have connectivity, as we know, on Earth, which is 4, 5, 6G, Wi-Fi 802, IEEE 802 with a RTT within that environment, a small RTT. We'll have multiple providers, multiple customers. So we're on the surface and orbits. It looks like an internet in the way of standard connectivity and multiple providers, multiple customers. On the space links, which means Earth to Moon or Earth to Mars, this is IP will be encapsulated in CCSDS space link frames. All the CCSDS has multiple link protocols, but they have defined a encapsulation, a generic encapsulation format that enables IP to be encapsulated in all those link protocols. We'll have long delays, so obviously as we're talking about the Moon or Mars is very different. Mars, for example, is about 8 to 45 minutes depending on the positions of planets. And we have intermittent communications, which will be discussed in the next slide. So the typical use case of intermittent communications is that an orbiter is acting as a relay or forwarder on one side, while the other peer is on the other side. It's typically known in advance, can be planned, as it's currently done for Mars, for example. But there's a lot of variability in this actual usage. Sometimes plan windows cannot be used. And if you're interested more in this topic, we made a study with JPL that was presented in the Deepspace side meeting on Monday. So therefore, we have different communication windows between each neighbor. So Earth to orbiter, orbiter to rover, rover to orbiter, orbiter to Earth, for example. Sometimes the windows overlap, sometimes they don't. So you cannot necessarily assume, line of sight from the source to the destination and back. So the key consequence here is that we need to store frames or packets on relays until the next communication window is available. That can be done at layer 2, as it's done currently on Mars. Currently, Mars orbiters, the 5 orbiters, are actually storing, frames, or actually bits. They even don't know the notion of a frame, and they are relayed to the other, like the rover or back to Earth. And so in this case, if you're on an L3 network over the L2 network that is taking care of the storage, then the L3, like IP or bundle protocol in that case, will be essentially unaware of the interruptions. It would be just more delays. Or you could do the storing at the layer 3 layer, like BP is doing, or IP would be doing. In this case, you store the packets for non-traditional time compared to what we do on Earth until the next communication, the next window communication is open. I'm not seeing the time, but anyway.
5 minutes.
Oh, okay. So, because I don't see the time on my screen here. So architecture key considerations, as I just said, there's a storage and forward to be done. And in this case, for whatever you do in layer 2 or layer 3 bundle protocol or IP, you need some kind of a buffer management and proper provisioning. Just to give you an example, the MRO relay orbiter who is orbiting around Mars was therefore taking pictures at different wavelengths of Mars, but was repurposed to be a relay and as a 120 gig solid state storage. This spacecraft was launched in 2005. And the Maros project, the JPL, is actually having that kind of a buffer management and provisioning tools. On the IP side, we already have all those tools available as we do today with queuing, active AQM, and policies that we do on forwarding. Transport. UDP is fine. TCP, is more difficult, I guess. So it depends. Obviously, the use case of Moon versus Mars is different. We've been concentrating on the more difficult problem, which is Mars. In this case, TCP, not going well. So we've been working more with Quick, and we did a lot of work. We consulted a lot of the Quick experts, and so currently it's kind of the two ways is where you set the transport config parameters to worst case RTT. We've been using the Quinn quick stack for that because it exposes most of the transport config parameters, such as for the quick people here, like initial RTT, max idle timeout, and those things and stuff. And we use only flow control. We're kind of making a simpler congestion control, if you want. But roughly here is the idea is to have the transport being unaware of intermittence. It's just variable RTT. So you kind of configure the connection as the worst case RTT. So we did that. I do not claim that it's the right thing, but we kind of at least try it out, and we demonstrated for a very large RTT, like 10 days. If you're more interested in this, there's multiple presentations in the side meetings for the last few IETF. Or you make transport aware of intermittence windows and do optimization. So this is kind of the best, on paper, but it seems to me a little bit more difficult. But so this is to say that we seem to have a solution for that, or at least a piece of a solution. Obviously, more work needs to be done, and this is actually an example of a charter item that we want to work on or propose to work on. Next slide. Oh, application and application protocols. We were not surprised, but there's a lot of application protocols that don't have timers, or just a generic timer. So if you set the timer appropriately whenever it's relevant, then it seems to be working fine. We did some simulations with many application protocols. So for example, if you run HTTP over Quick, thinking about just the last slide about Quick, HTTP has by itself no notion of time. It's just a few headers that have time, like the caching headers. So if you set them appropriately or you do not use them, then you can run HTTP over very long. And so we demonstrated with the 10 days RTT HTTP request and response. And obviously the applications need to implement the synchronous patterns. If you want to deploy a network like this, you need also network services, and one of them being DNS, and you really want to avoid DNS resolution over deep space links, RTT. So we actually had a discussion with a few DNS people, and so there are different ways to do this, but roughly, and they don't need necessarily a new TLD or a new something. In one sentence, you're making sure that all names and all the key material and trust chain that are needed to run on Moon or Mars are remotely, that are needed there, are prefetch, push, or cache with careful TTLs on DNS records and stuff like that. Next slide. And that's the last slide. Okay, so in terms of deployment, there have been considerations of using transport proxies or ALG at Space Edge, which actually makes sense. Example of this could be a quick proxies and maybe using mask. So there's different ideas floating around, but frankly we haven't looked at these. And as you have seen, the timeline really is Moon for now and Mars later. And I have a...
That's not presenting.
I know, just concluding remarks. I'm nervous here and want to just don't forget. Concluding remarks, you may think that, we haven't done everything, haven't looked at everything. So you can think about the protocol, like, we've been talking about CoAP or header compression or others, but the idea here is we really want to set a small set of work items starting now. And we have done many simulations and protocols in the testbed using Mars as benchmark, but we do not with packet loss and all that stuff, but we don't pretend anything in terms of this is the actual solution.
All right, thanks, Mark. We acquired quite a queue. I want to sort of remind people that ideally we would stick now to clarification questions on Mark's presentation and keep sort of the broader scope and should we do this questions for later. So let's give this a try. Philip.
Hi, really great talks. I was just going to say that on the HTTP side, some interesting stuff on the caching piece, in that traditionally the assumption in HTTP was that if it was in the cache, it was non-confidential data. For something like this, we could start getting into some interesting thing where the stuff in the cache is encrypted and interesting ways to share it, like SHTTP and Shen proposed in the mid-90s. So interesting crypto stuff as well.
Josh.
Hi. So on the slide where you showed the intermittent communications, so two questions. One is, why not deploy, like, let's say 4 or more satellites so that there's always one in
Covered.
communication?
Yeah.
And the second is, why not put them on the surface? Is that because the atmosphere?
Sorry?
Why not put the transmitters on the surface instead of an orbit? Is that an atmosphere?
Oh, okay. So first question.
Hang on, this is not really something that the IETF has much to say about, like where space agencies put their satellites. Right?
Well, but there's a, okay, let me, short answer. So, you know, for Mars, which was kind of the benchmark we were using, you know, having a relay on Mars costs a few $100 million. So until you get full coverage, you know, you will have to deal with intermittent communications, right? It may happen sooner for Moon, and as Wes actually showed, there's plans to have this, but even on Moon is still, you know, a good cost. So therefore, you know, you have to plan with intermittent communications. So.
Gory. And if people in the queue can keep an eye on the queue and maybe already make your way when you're next, that would help us a little bit saving time. Looking at you, Jörg.
Okay, Gory, I was curious because you mentioned quick so many times, and you mentioned like lots of things have probably changed. So the two questions were very quick. How much of quick remains the same, and how do you do the flow control? You say you do with like 40 minutes of time?
Yeah, good question. So how much quick? So again, I'm not sure what we've done is the fully right solution, but you know, it's like a proof of concept. So again, what we did was just change the transport config, what I just said. We have a Quinn workbench, which is a way someone actually, Adolfo actually created, so you can simulate all kinds of conditions, network conditions and transport config, all in the same thing. And for flow control, this was more like a test because, you know, flow control pacing with that kind of large RTT is, at the time you receive the signal to pace down, it may be just too late. So I'm, you know, like BP doesn't have any, bundle protocol doesn't have a pacing by itself. So pacing, I was seeing more of this in some specific cases, like if you have a 4K video coming in for like an hour and, you know, it kind of gets, you know, the buffers being too, you know, full, then you may having that possibility. But so we tried that, but I'm not sure if flow control is you know, the right thing to do. It's a question mark for the moment.
I suspect you're saying you threw the flow control out as well, rather than you're sending stream credit updates every 40 minutes. So
yeah, so you know, frankly, the transport part of it is you know, needs work. That's why we're proposing a working group.
Jörg, just quickly, having tried to build disruption-tolerant applications for quite a while, you had your applications conveniently stop at DNS and HTTP. I certainly agree that the internet mostly is DNS and HTTP, but their timeouts won't matter. Normally you have, whatever you have nowadays as mobile applications fail because the code on top that just uses HTTP as a transport is broken. Yeah. So by stopping as HTTP, you're not fixing anything. I just want us to keep that in mind.
Agree. When I'm talking to this about this project or topic, a lot of people come and say, well, my internet application, you know, won't work. Yes, this is not about, you know, internet applications as we know, but, you know, space applications, you know, well created with proper timeouts and stuff. So very asynchronous communications design.
I understood the whole point of the entire exercise was to make good code reuse possible, and that would certainly not stop at application code. So I'd be careful with that statement.
Oh, well.
Keith.
Yeah, sort of two questions about the Quinn testbed work that you were doing. One is, with security protocols, can you set quick so that it, you know, essentially how do you manage security protocols and stay away from anything that has to do round trips, end to end in order to establish a session?
Roughly it goes down to key lifetime. So both the identity of the peers and the session key lifetime. So that's where what I just said applies to any protocol that does encryption, right? So in space you need to make sure that your key lifetimes are appropriately set for the kind of RTT and deployment you have. So if you run IPsec, for example, it's the same thing, or well, even BPsec, right? You need to be careful about the key lifetimes.
Right. And then the other question was about the Quinn testbed. Does it handle like an internet piece and a space piece, or is it essentially one link?
It emulates a network with conditioning, so it could be as a large network as you want. When I'm done, I'll put the link of the workbench on the chat, so for people to refer.
Awesome, thanks.
Alexander.
Yes, thank you, Alexander Pelov. Thank you very much for the presentation. And one thing I think it's really nice to see is how these deep space communications relates also to IoT and things that we've seen in IoT. So
yes,
they're quite different, but
yes.
So there are two things, and actually thanks for the question. One of the questions beforehand was, okay, so we're using IP, but then maybe you need to change some timers. So is this still IP? And actually, well, we have experience with that, and we did a lot of IP-based protocols that were not working well on IoT networks, let's say. And by having IP, we just needed to change a couple of timers, and it all worked. So we got, for example, running SSH on LoRaWAN networks. So these are super, super slow. SSH was never intended to work on this kind of RTTs, and it worked by only changing a timer in the existing code.
Mm-hmm.
So I think that's super powerful. It's a proof that it runs and it works. So going to 45 minutes, maybe it will be something more, but
IoT and space have common characteristics like low power, low bandwidth, intermittent communication. So, and for that exact reason, we had multiple presentations about CoAP, using CoAP, and then SHIC, which both are targeting first the IoT environment, but could be. We probably need just a profile to make them work in deep space. So I completely agree. We tried SSH on our testbed. It didn't work at all. And we try, hacking it and, for example, not sending the echo each characters, but sending the whole line. I was looking for the new proposal of SSH3 over HTTP. But it never been accepted in the current discussions for the IETF. So I would really like to get how you did it for SSH, but it didn't work in our case.
Of course, and just if I can add, for example, when you were talking about proxies and things like this, and Philip mentioned about maybe you need to have some kind of elements that are hidden and that are protected, encrypted, and maybe some others that only have integrity on them, and others that can be changed in the intermediate elements. So that exists in the IoT world as well. For example, in CoAP, you have the thing called OSCORE, and then you can have all these concepts that are already there. But one thing that's really important is that I think that you cannot just take things as they are today. So there need to be this special work in this potential in this future working group that will need to look at all these protocols from this angle.
Yeah, essentially, as my concluding remarks, there's different other pieces that that may be folding into this work, but we're going to the charter discussion soon, and we're also the ISG prefer narrow scope stuff and then large things. So that's the current plan.
Rick.
Rick Taylor. clarifying question, Mark. So we heard from the previous two presentations that a lot of existing space missions and future space missions from agencies and governments and private sector as well are looking at a dual stack.
Mhm.
So they've got bundle protocol in there and they've got IP for that sort of real-time-ish connectivity. In your architecture proposal here, you seem to have, we've stepped into, following on from the previous question, a kind of a proxy sometimes, a store and forward sometimes. Are you proposing that store and forward is part of the overall architecture?
I think
Because
we
this
should.
is the first time I've heard of it, and the chairs
Mm.
may say, shut up, this is the next
Yeah.
Q&A.
Yes, because I think we, until we get enough orbiters into around Moon or Mars, then we'll have to deal with intermittence. So therefore, we need to do storage and forward, and that could be, as I said, it could be even transparent for IP or even for BP because it could be dealt at layer 2, right? So as it currently being done on Mars orbiters, right? In this case, the layer 3 doesn't see it. It just doesn't see it.
Thank you for that clarification. So when you're saying store and forward, you're saying lower layer, so layer 2 in this example.
Well, it could be, or if you do it on layer 3, then you store the packets, longer than what we used to do on internet, right?
I'll come back to this later when we get into the charter discussion,
Sure.
but I think it's an important point that we need to be really clear about. So thank
Sure.
you.
Thanks. Alan.
Yeah, this is Alan. That was sort of my point too. I mean, if there's hours or days between point A and point B, the multiple participant nature of IP and TCP is completely useless. And the only thing that works is point to point, store and forward. So your transport is less IP than FedEx, right? That's more the model that you're using. Everyone talks to one location, everyone local talks to one location. That one location then talks to the other. Because there's no way to do balancing of TCP sessions.
Yeah, TCP is a bit, especially for Mars, it's a bit out. But what you're saying is not far from reality in the sense that if you look at orbiters, the way the antenna and communications are done is they don't talk to too many at the same time. So it's mostly a point-to-point based network, right? With multiple ups.
So
and each link is actually a point-to-point link.
Yeah.
So
if I want to talk to Mars, I talk to my local hop, and that one local hop talks to the one Mars.
The orbiter, and then which makes a lot of sense, for example, for header compression, because bandwidth is very limited, and all those links are actually point-to-point. So header compression is just like simple and useful. So.
Suhas.
Thanks, Mark, for the presentation. This was very useful. I have a couple of clarification questions. One is that what kind of applications are we envisioning to run? Is it more like a file transfer kind of an application, or versus something like a messaging or audio video kind of media? The reason I ask is that because each of these applications have a different requirements on the application transport protocol that we use, and one protocol does not fit there, even if it's on IP as the I would say the network protocol. And the second question, follow-up question on that would be, I think some of the concerns about the store and forward at layer 2 and layer 3 and the capacity that you have, especially when you're let's say you're running a media application that's doing 4K download of something that's happening on the Mars or the Moon. Then those buffers are pretty useless at that point in time. You need to have application layer store and forward more, or the application transport layer store and forward. So do you have any thoughts on in general on this?
Yeah. So first question was what kind of applications? So at least the ones that the space people are doing right now, which is essentially commands that you send. So very short strings of commands, and you receive back status, telemetry, and stuff. So they're currently doing with a file transfer. So file transfer and request response kind of environment. The other thing is images and videos. real time, including the fact that it takes a long time to come back, but right. So certainly those kind of applications, and then all the control plane for the spacecrafts. What was your other question? Is buffer? Yes. Whatever you do, you have that problem. So if you do store forward, store carry and forward, whatever the name or buffering, if you do out layer 2, you have that problem. If you do it with bundle protocol, you have that problem. If you're using layer IP, you have that problem. So whatever you do, you need to manage this. And that was like one of the point of my slides is there. The interesting part here is that we do have a rich tool set within the IP stack for managing, queuing management and traffic policies and all kind of stuff. So, but you're right that this, and that has been discussed a few times, and you actually showed something Monday where we can put that put this more on the proxies kind of architecture edge, proxy at edge, space edge, or so this is kind of a deployment discussions that we can have in terms of which layer is the right place. And my take is it depends on the network provider, the application. We may see different deployment cases depending on the use, as you kind of infer in your comment. But the good part is there's no restrictions, to me at least for now. I haven't seen a restriction to have a mix of deployment scenarios, right? Where some may use proxies and others. I was talking about Mask, which seems to be a good, and was actually proposed by I think it was Magnus that proposed a Mask architecture, like 6 months ago on the mailing list. So.
I agree. I think something at the application transport. I think as we go further to think about is that like is it application transport thinking is an end-to-end or a hop-by-hop is something that we need to consider into the charter discussions. Yeah, thanks for the point. Yeah,
sure.
Thank you all. That was quite on topic towards the presentation. So good job. So you probably sort of seen that there's question marks here, right? And there's while there is some overlap between all these different intended users of IP and quick in space, there's also some disagreement or some things that maybe only one or two of the intended deployments want or need and so on. So the chairs and the AD and the programs, we spend quite a bit of time on various calls, as you might imagine, and we sort of try to come up with this sort of crisper expression of scope, which is also known as a charter proposal. And so my suggestion would be we go through it and ask if there's any sort of scope or clarification questions on the charter text before we then go for the all-out anything goes discussion. Right. Let's do this. Right, so this is basically this should be the exact same text I sent to the mailing list a couple of days ago. If it isn't, that wasn't the intent. So this should be word for word identical. Right, sort of the charter starts out by saying some space communications involve long variable delays, e.g. Earth to Mars is 4 to 20 minutes one way, and intermittent end-to-end connectivity due to orbital dynamics. Until now, space communications have relied on layer 2 point-to-point networking, sometimes involving relays, without establishing an end-to-end layer 3 network. Today, space agencies and the private sector are planning to deploy IP networks on the surfaces of celestial bodies, such as the Moon or Mars, that connect to orbital equipment and further onto Earth, establishing a complete end-to-end IP network across space. However, given the delays and disruptions involved in space communications, protocols may have to be profiled to operate efficiently in this environment. Is that clear? Do people understand that sort of scoping? Are there any questions about that first piece of the charter text? Stephen and Alberto. Stephen, go ahead.
Stephen Farrell. The first question is a question. So I want to disagree with a bit of this. Is that a scope question?
Let's see.
Okay, so I mean, I think the scope of including Mars distance makes this probably a bad idea, including moon distance probably makes this a good idea overall.
Right, so you're basically saying you would feel more comfortable if any working group would only focus on lunar networking in the initial phase. Okay.
And you know,
point taken.
Because it's much more tractable, and if you try and consider the Mars distance and how you adapt existing internet protocols and applications for that, it's dozens of times much more effort to get anything done, as well as being technically more challenging. There's so many other things you've got to consider that which at lunar distance might just about work.
I agree. So we had this discussion also with the proponents, and I think the main reason why the Mars scenario was considered in scope was that there was an ambition to have an architecture that would support, or at least have the beginnings of the necessary support to include the Mars use case. And there was at least felt that excluding it from the get-go might lead us to an architecture that works great to the moon, but basically we need something completely different to go further. And you know, we can argue whether that's true or not, but point taken. And maybe when we come to any hums later on, we actually, since I saw a bunch of people nodding or doing +1 when Stephen was speaking, maybe we'll actually explicitly ask the community whether they think what scoping would make sense. But thank you. Alberto.
Thank you. I have two comments related to the charter. The first one is, you know, from the first paragraph, it seems the first paragraph implies that one of the goals is basically address delay and disruption tolerance for the IP stack, which is great. However, during the initial presentations, there were also implications about how to deploy on the surface, like, you know, the local networks or the local IP networks. So I think that if it is both, that has to become clear on the charter. If it is one of them, then have to be clear on the charter. That's my first comment. And then the second comment is that...
Hang on, let me respond to this one first. So that's excellent. I think when we wrote that text, I think we assumed by not saying anything, we were also like implicitly making the assumptions that the current terrestrial internet would work for deployments on other celestial bodies. If that's not clear, or if that's not the case, we should definitely add something that says we make that assumption, right? Or we assume that to be true.
Yeah, because I think that the main difference is when you think about the local networks, you have in presence the application, the end user application, versus if all you are doing is trunking, then that's a different story. So I think because, you know, we already discussed at some length the implications, you know, delay and disruption has on the end application, irrespective of the protocol that we are using.
Okay, thank you. You had another point.
Yeah, the other point is that the charter seems to ignore the work and missions that have carried DTN or bundle protocol. For some reason, it says that without establishing, I think there is something to say here about bundle protocol, and the reason is the following: they would need to interoperate, even if it is not a charter here. Bundle protocol-based networks are going to be there, and
so
we cannot just simply ignore them.
We had a discussion, and I think an earlier version of the charter basically said interoperability with the bundle protocol remains like with the DTN working group. And we, at some point, we made a pass where we explicitly removed a lot of text that talked about things that weren't in scope, just to like crisp it up and make it shorter. But if that's a clarification that you think is important, we can certainly add something like that back. Thank you.
Thank you.
Philip.
Yeah. The last sentence, some protocols may have to be profiled. I think you need to also say or extended, in that there are things that I would want to do to HTTP in this area that are definitely not profiles, but they are much more in the nature of extensions, because, you know, HTTP is designed around one set of assumptions, which made certain approaches unappealing. And this is a separate set of assumptions where those approaches are much more relevant.
Fair point. And so I should remember this, but I don't. I think there's text further on in the charter that talks about extensions, and it basically says the usual thing that they would need to be done in the working group that maintains that protocol. So if this work would not just be profiling existing protocols, but requiring extensions to deliver what it needs to deliver, those would need to be done, for example, in HTTP BIS or QUIC or DNS or TLS, what have you. But maybe we can, in this line here, also talk about extensions, because we're going to talk about them later anyway. Thank you. Robert.
Hi, hello. This is actually not Robert, but Felix Flentke. We are here at the CCS meeting on the DTN working group. And myself, but also my colleagues, we have some problems with a statement in the second paragraph, which seems to imply that space agencies are seeking to establish a complete end-to-end IP network across space. So this is not true for the space agencies I regularly interact with. So I'm from ESA, but I think that's the same position of NASA, JAXA, and other space agency. And in particular, it's also not in line with the current discussions and documents we have at IOAG. So I think the first part is fully correct. We want to deploy IP networks on celestial bodies. What we explicitly don't want to do is a complete end-to-end IP network across space. So I think this needs to be reformulated or changed.
Okay. Would the insertion of the word "some" before space agencies clarify that?
If you know some space agency which is planning to do that, more than one, then you could put some. But I think currently, as far as I know, it's not correct.
Okay, fair point. So as a non-space person, I get the distinct feeling that these space agencies are very multifaceted, in the sense that you talk to people and they all say, well, we do. Anyway, so my point being, we will think about a rephrasing that is more accurate. Thank you.
Yeah, but just to say, there are certain bodies where space agencies coordinate, like the IOAG. And the IOAG has a document on space internet working, which explicitly discusses the lunar case and explicitly says it's not about end-to-end IP connectivity.
Okay, so I think there might be we need to figure out what a good statement would be, because I did hear from some other proponents in the space that is actually the goal, that the lunar networking case is looking at a Earth to Moon and
Not the goal
IP
of
network.
lunar.
I'm sorry?
I'm sorry. I mean, there's a LunarNet interoperability specification, and there's no notion of end-to-end IP for LunarNet. It's also not correct. This also has not been correct in the presentation before.
Okay, we'll strive to be more correct. Thank you. Suhas.
My comment was a clarification question on what does end in this mean, other than that in the charter should clarify what end-to-end means. I did not get, I got like 3 different definitions from the previous speaker and the presentation. So if you can clarify that, that would be helpful.
So end-to-end is like a usual internet phrase, which means from one sender to a receiver, and from one network endpoint to the other, like the end of an IP interface, a thing with an IP address.
Okay, sorry, thanks.
Rick Taylor, following on exactly from that question and my previous question, I think the store and forward relaying in a sort of mask mock style or a bundle protocol style should explicitly be out of scope for this working group, because there are other working groups in the IETF working on it. And I think that clarity is important.
Okay, so in other words, you think we should focus on the end-to-end use case when there is line of sight direct communication possibility?
Yes.
Okay.
When you can establish a single layer 3 round trip from source to destination, and this is dropping close into path-aware stuff, and we need to be quite accurate about what we mean. But if we're starting to say, well, we can do HTTP proxy to HTTP proxy in order to maintain end-to-end, that starts to become more of a general purpose store and forward mechanism and less about an IP protocol profiling.
So at a follow-on question for you. So there's a spectrum here, right? There's
Yeah,
there's
there
the
is.
we always have an end-to-end path. There's the we never have an end-to-end path with like we can only communicate with store and forward. And then there's like the gray part in the middle where sometimes we have an end-to-end path, maybe mostly, but then sometimes not. And what sort of variability in the availability of that end-to-end path versus not having it where would you draw the line between what we should consider in scope or out of scope? Is it must always have an end-to-end path, as basically like we have on the planet Earth, or is some disconnection possible?
I think it comes down to if the protocols that have to operate in that environment need a complex control mechanism to manage the buffers and the retransmissions midway and the security at rest and all those hard problems, then there are other working groups in the IETF and in other SDOs that have spent time and effort working on those problems. And I think people interested in continuing that work should go out to those groups, and we shouldn't have yet another go at it. I think we'll waste cycles when we can do important stuff.
Got it. So scenarios where like simple logic, for lack of a better word, might help us deal with some disconnectivity is sort of okay to do, but anything that requires, complex solutions, as you said, would be out of scope. Okay, that's helpful. Thank you. And we are acquiring quite a queue, and we do have a few sites to go to. So try and be succinct. Gori.
A comment on why do we bother to saying some space agency and private sector are planning and just say some people are planning? I mean, from dealing with space agencies, they really don't like you buttonholing themselves. So just a thought.
Yeah. I mean, some people sounds like my son is sending a rocket up on New Year's, but so we wanted to show that it's a little bit more, an actual thing that's in deployment. But we're happy to see phrasings like that. Maybe you can sort of also ask that if this is not a reaction to Gori's question, but figure out if your point on the charter text is really at an importance level where we need to raise it here versus whether we can stick it in an email and fix the text sort of offline. Thank you.
Yeah, the real reason to come into the bite was I think some level of disruption is inevitable on these paths. This is not something where you really get a line of sight communication like you might have in a radio link.
Would you be okay with a formulation like Rick sort of hinted at, that we talk about like low complexity situations we're going to be trying to deal with, and anything more complicated we're not?
Something like that. I mean, not the... Yeah.
Okay, thank you. Brian.
Hi, Brian Trammell. I feel like I was summoned because someone said path aware a few times. So it's path aware 3 times I come to the mic. Panergy is after this.
Don't say path aware in this working group, please.
Okay. Okay. Sorry. I did want to point out. I did want to point out one thing. I think that like we're only going to do the low complexity end-to-end stuff here doesn't actually solve a useful problem, I don't think, because in a lot of cases you've got something happening up at the top layer, right? And if there's not some sort of adaptation between, okay, I have a low complexity thing to now, oh, well, I'm on the backside of whatever and there's a relay thing. I think that it makes a whole lot of sense not to do sort of like network layer magic in this working group that's already been done in other working groups. I think that it should be in charter to consider how you have a workable end-to-end service that works not just when the stars literally have aligned for you.
Okay, so in the spectrum of complexity of scenarios, where I don't know what you said. You said we should do simple end-to-end only.
I think Mars is a distraction. I think the dark side of the moon is probably something we want to be able to reach.
Okay. Yeah. Thank you. Alexander.
Yes. So I just wanted to react, but I think that it's from what I hear a little bit a consensus about the end-to-end nature of the communications. So I think we should not limit it only to direct line of sight communication, right? Like if you need to hop from 1 or 2 hops, like it's the way IP works. Like, and if it needs to sit on a router somewhere around something that is for a couple of days, like it's a delay in the routing. Right, something like that. So end-to-end for me, it's in the charter and not only for line of sight.
I think that was what Rick was getting to, but I think if you look at from a perspective of a single flow, right, the packets might be sitting in the router for a few days and it's not complicated. But if you have 100 million flows and they all do that all the time, the solution to manage that has some complexity that probably, as Rick said, is too much for this working group to tackle initially. That's at least how I understood him. Right, and Alvaro closed the queue, which is great, so we can go to proposed charter page 2. If you have other suggestions, you can obviously also email them to the mailing list. Right, so the next part of the charter has a bunch of bullets which are intended to outline individual work items that the group would do. So to continue reading here, this working group will work on the following items. Bullet 1, documenting the key characteristics that make the space environment unique and considerations for properly designing space applications will be provided. Bullet 2, work on an architecture for using the IP stack in space that discusses the key differences to terrestrial IP use. While lunar networking is the first deployment of this work, the overall architecture should support communication with Mars and ideally further out. Questions on that, Stephen?
So the Mars thing we dealt with before. It's not clear to me that we actually want to work on a new architecture or see how much of the existing architecture for internet applications breaks when you try and put it here. See what I mean? I don't know if developing a new architecture is what's needed. It's more finding out what of the current architecture breaks or needs adjusting or tweaking.
Correct. So I think maybe the wording is unfortunate. So it doesn't say new architecture, which is good. But I think it maybe to use the word profile again, maybe a profile of the IP architecture in space. But yes, the intent is to basically look at which are the things that we need to like tweak or do a BCP on that says something that's maybe different because it's space.
Right, but yeah, so
we
so
wouldn't
not
do
developing novel,
yeah,
you know.
no IPv10.
Right, no novel architectures, because we always invent them afterwards anyway, right?
I saw a whole bunch of people go, oh, when I said no IPv10, by the way. Rick.
Very quickly, I disagree with that first bullet because that's RFC 4838. We've already written that.
Excellent.
Yeah, so let's not do that again. But exactly what Stephen said. Sure, compare and contrast, evaluate gap analysis, blah, blah, blah. Use cases, that's great, but not that bullet.
All right, great, thank you. Max.
Does space specifically include LEOnets here, or is it, or what is space?
Does it include what? Sorry.
Sorry, low Earth orbit networks.
No, the low Earth orbits are not included in this proposal.
Okay, then maybe it should be more clear because space can maybe be a bit ambiguous.
Okay, we'll try and clarify. Thank you. David.
David Lamparter. The last sentence sounds very much like any architecture document needs to support Mars, and that would prevent us from doing something that is lunar only. I think we want to allow documenting things that are moon only for the time being and have separate documents that tackle moon and Mars.
Yeah, so as I tried to explain, we try to find the phrasing that says lunar is the immediate deployment scenario, and it would be awfully nice if, as we looked further out, we wouldn't need to start from scratch. We need charter text that sort of gets that across better, because it's been brought up several times now, and okay, we didn't do a good job, thank you. Britta.
Yeah, the second bullet there, when we say work on is a little bit ambiguous, and to reiterate or to echo the prior thought, we might not be wanting to do new architecture, but we most certainly are going to need to make adaptations to existing protocols as we get into this space.
So work on was supposed to like write a document. That was like the intent, or.
Yeah, but is that like the documentation? Is that compare and contrast? Is that adaptation of current protocols and so forth? So I think it's worth being a little bit more explicit when we say work on of what that actually means here.
Yeah, fair point. We might have taken the shortcut to not like fully wanting to figure out what we would do and just like leave it ambiguous, but thanks. Yeah, good suggestion. Alberto.
I want to go back to the lunar versus Mars, and I have heard quite a few comments saying, "Hey, we shouldn't focus about Mars." But I think if we leave space expertise aside, the technical problem we are dealing with here is delay and disruption tolerance. So I on the second bullet, when it says in space, I think we need to technically qualify what that means in that bullet, which is we are talking about in presence of delay and disruptions. that are typical in a space, but not only in a space. You know, if we think about underwater communications, we have a similar scenario. We think about, you know, challenge networks, we have a similar scenario. So
Yeah,
I you know, would vote for or
fair point.
propose
We had
to
that on
stay
the
away
previous.
from.
We had it on the previous slide in the beginning of the charter, and so maybe this is me as an editor. I felt like repeating that again felt like a little repetitious. Is that a word? I don't know. But if it helps the clarity, we can certainly add that back and repeat it again if people think it's important. Thank you. Jenny.
Hi, Jenny Ko. And I just want to agree that I have an issue with the last statement just because it sounds like a lot of the work will be focusing on lunar networking. So what is the problem with taking something out and then reevaluating later on? And if you want it to be part of the charter now, then I think the design really should, it does really sound like it needs to support Mars rather than a reevaluation later on.
Okay, thank you. Keith.
Yeah, I think this question of Moon versus Mars is sort of the crux of a lot of this, right? There are lots of things that I could see extending the IP architecture and tuning protocols and maybe application buffers and things in a way that you could get a lot of use, you know, at the Moon. But I also think that a lot of those approaches just won't work further out. So figuring out, I don't have a good answer or even a suggestion, but I think that both of the, I think that extending the IP, I personally think that extending the IP architecture to Mars would be quite difficult. But I do think we need to figure out which pieces of this we want to tackle. Over.
Thank you. Alexander.
Yes, very, very shortly. So I also agree on focusing on the Moon, and I wrote in the chat something like focus on Moon, but any solution should not exclude possible future Mars communications.
Okay. Point taken. Robert, we did close the queue, but if you want to go real fast, please go.
Hi, this is again not Robert, but
Okay.
CCSDS group here. It's nowhere written in here on any consideration of how security will be handled. So I just wanted to clarify if that can be something that's going to be considered on the working on an architecture for use, or if we need to do any kind of evaluations of existing security protocols, perhaps that would be suited for space, or I just wanted to have security be built in here and not as an afterthought.
We're getting a bit of typing sound from your end, so maybe the person closest to the mic could stop typing for a second. So security is an awfully broad term, right? And if specifically, since Quick is the protocol that's being proposed here for application use, that has TLS baked in, and so it does address quote unquote security in a particular way. I wonder if you have other things in mind when you mention security. Do you mean like at the IP layer, at the routing layer, at the DNS layer, or can you say a few more words about that, please?
Yeah, so in regard to security, so yes, you're right, with Quick and everything, there's some amount of it built in, but not all security protocols have built-in key exchange, for example. So there's quite a lot of security guarantees that haven't been addressed by existing security, by existing protocols that are being used. And it's kind of a, it's worth looking at, I think, more so in depth. Especially for example, we've been talking here about BPSec and the use of symmetric keys as a basis of trust.
Okay, thank you. So I wonder if we added security explicitly to the second bullet here and talk about it in basically investigating the gaps to the IP architecture in a terrestrial use case, including the security of the IP architecture, if that would sort of address it.
I think so. Thank you.
Okay, thank you. Britta.
Yeah, just addressing that last comment about TLS and Quick and security already being built in. The TLS handshake in Quick is designed for terrestrial networks where latency isn't all that much of an issue, where you don't really have an issue also with session-based key establishment and so forth. And it's not inherent that we always have to take Quick, if you look at it as a full stack protocol with that handshake. And these are the sorts of questions that I think is worth addressing or worth bringing up over time as we get into this space, no pun intended. And so we were just saying, as we look at the different protocols, we probably will be looking at adaptations. You know, we are looking at a different use case, and that goes across all the network stack. So probably wise not to simply say that we need to glue together existing protocols, but actually look at how to optimize.
So just so I understand correctly, you're saying we should look at other protocols than Quick because Quick's security model has some issues, or are you saying we can replace the Quick handshake with a different handshake? It's been done in research, right? There's I forgot the crypto framework that they use, but there's been a bunch of research papers where they basically went with a different handshake, had different properties, and you're saying maybe one of those handshakes with Quick would be something that would be advantageous in space.
I'll say yes to all of the above. We're working on a different set of playing rules once we get into space, and instead of taking what we've already designed and simply going drop in, it must be used as is, we should at least keep the aperture open to say we can make adjustments and look at adaptations as needed, and we'll at least consider that, and that will actually, as not bring back up the Mars question, but as we get beyond lunar, then some of this might actually extend better.
Yeah, thanks. That makes sense. And I think we did say, I mean, we talked about profiles versus extensions before. That would certainly be an extension, and it would certainly not be done here, but probably be done in the Quick working group with like input, and it would really be their decision if they wanted to sort of do this. But Quick is pretty extensible, so there's a flexibility there. Alvaro, 10 minutes. All right, let's read some more charter text.
We should do this and then stop.
Right, so this is the continuation of the work item bullet list. So this would be bullet 3 now, if you look at the full charter. A profile for the Quick transport protocol that enables efficient end-to-end use of Quick in space. Given that TLS is an integrated component of Quick, considerations for the use of TLS are also in scope. And the fourth bullet is considerations for the deployment of DNS will be documented given the often disconnected nature of space networks. And grain of salt, we talked about lunar versus Mars and beyond, and maybe it's not quite as disconnected as this text sounds, but that's what we have. And then other topics, including the bundle protocol, are out of scope of this working group. I have a bunch of people in the queue. Please try and be brief. Sauli.
All right, I hope you can hear me.
Yes.
Based on the previous points, it was pretty clear that the kind of complementarity to the bundle protocol that was claimed is on just increasing buffers and timers on layer 3 or layer 3, whatever is the approach, and we can get some cool effects out of that, even what was echoed by Mr. Pelov. But now I have a concern here, because all the previous presenters, first 3 particularly, were highlighting that we need more transport layer solutions and we need more application layer solutions, and even what was now just mentioned by Britta. But then this page, what you have now on the screen, is explicitly saying to us that we shall only focus on Quick and everything else is out of scope. So I have raised this issue already before in the mailing list, and I would like to raise it again here, that I don't think this is a very, very good idea based on the needs what we have. Thank you.
Thanks. So this was a discussion that we had, and in order to scope down the proposed work, we specifically limited it to the IP architecture, Quick as a transfer protocol, with TLS as an integral part of Quick being part of that sort of Quick discussion, and DNS and naming. Point taken that if people want to add to that, we can discuss it. The ISG typically likes to have tightly scoped working groups, and so we would need a pretty strong argument in my book to work on additional protocols. Stephen, and we closed the queue, and because we have quite a few.
Sure, I'll be quick.
Be quick, all of you.
I don't have a problem with the idea of starting with Quick and having succeeded there, do more stuff. I do not understand why DNS is seemingly the only bit of infrastructure needed to support Quick, because that doesn't seem like it's true. You kind of need addresses, you need a web PKI or some type of PKI, you
Correct.
need a whole bunch of things.
The intent was that was part of this architectural considerations bullet on the previous slide, so we would talk about those things there.
So as a suggestion, if the second bullet basically said, and the stuff you need for the first one, such as DNS, that would be more.
All right. Keith.
Yeah, so I think we need to consider how any of these proposed extensions or adaptations affect operation over the internet, right? So are we talking about something that we're going to make these adaptations and those applications and protocol stacks are only used for the space communication, or are we really extending the internet in that I have the same set of applications on my desktop and I can talk to other things on the internet as well as things that may be across space links? Over.
So I don't expect to have any application on my desktop that can talk to the moon. If I'm wrong here, that would be really cool. But I think there might be some security aspects that we want to look into. So I thought we would be talking about a sort of sector-specific space applications that would be using this sort of sector-specific IP profile of the internet architecture and QUIC to enable space sector applications that wouldn't like run on your and my, well, maybe yours, but definitely not my laptop. Jenny.
Hi, two short notes. One, I think that as someone who's personally kind of new to IETF, and I think for a lot of people who are outside of IETF looking in, I think it is a little confusing, like completely separating out BP and not mentioning at all other than this note at the end, because the DTN work, the documents mention their interest in space and applicability there, and here obviously it's dealing with delay, even though it doesn't use the exact term, it is dealing with delay and disruption tolerance. So I think if there is some more, like some document or something more in the charter specifically addressing that difference and making it more clear why these are separate working groups, that would be really helpful. And then my second note is that I feel like that saying explicitly that BP is out of scope for this working group, I understand why it's there, but it sounds like that we do want to work together working forward because both can exist and both will exist to some extent. So then it seems like it'll be an ongoing discussion to where such documents will live. And so I think it's a little, I don't understand why it specifically said out of scope rather than saying that will be something to work on.
Yeah, so this is an IETF phrasing that basically says, the DTN working group has this scope and this working group might have that scope, and there's no overlap, so there's no interference in the work. But I think one suggestion that we can certainly take is that we should specifically look at the output of the DTN working group to see if there's a document that was mentioned earlier that was already done, right? To see if there's any output that we can use as input for this working group without changing it, right? But basically making our job easier by referring to somebody else's already correct content that has been published, and maybe clarify that, they're both in the same general area. The DTN working group has done a bunch of work, some of which sort of can definitely inform what we're doing here because it already describes some of the characteristics that we're interested in.
Yeah, and so I think working together is very important on that specifically, but even outside of that, if there are to be documents on specifically how BP and IP will be working together, then I think this just makes the onus completely outside of this working group, when I think some people in this working group might be interested in that documentation. So I think it's kind of limiting when I think it could be more flexible.
It would be a discussion with the DTN working group whether they're comfortable with this working group doing that work versus doing it maybe over there, but that's something that we can talk to the ADs about. Thank you.
Thank you.
Britta, and we did close the queue after Britta.
Yeah, so in terms of narrowing down, we have it narrowed down here to QUIC, which makes sense to narrow it down. I'll start there. What doesn't make sense to me is the use of TLS. That protocol, in particular for space, just is begging to be broken down.
You think even for the lunar use case?
Even for the lunar use case, we're right at the edge of its operation, basically. And to the point before, it's not necessarily an inherent part of the whole QUIC stack. Yes, QUIC as currently defined is that way, but it is a handshake, and we can be looking at these as modular components, and that could be something discussed out in QUIC. But as this first bullet point is currently stated, it is gluing us to TLS regardless of that.
Fair point. Yes. So let's take this offline to make sure that we're saying the right words here. And Mark, I'm going to come back to you later, but not now. Very briefly, I want to look at the other two slides. I'm not going to read them, but basically, this says things I've already said before, right? We're avoiding modifications to protocols, and we are trying to reuse existing work rather than to build something from scratch. If this working group would like to see modifications to existing protocols rather than profiles, that would need to be done either in the working group that's taking care of that other protocol or with the agreement of that working group here in this new working group. And the area directors have obviously also something to say. Next slide, we're basically talking about who are some of the other entities in this sector that we should sort of liaise or coordinate or exchange information with. If we're missing something, let us know. This is sort of the entities that were brought up to our attention within and without the IETF. All right, and that's sort of the charter. And thank you all for your feedback. I think that was very useful. The discussion we've had, so I'm going to go forward to next steps. And this is where we want to hum. And I actually think I want to do a clarification first. Oh, not a hum, it's a show of hands now. So we're going to do a show of hands using the MeetEcho tool. So get your phones out and log in and do all of that while I'm talking on the lunar only versus lunar plus, let's say, Mars. And you're going to get 3 options for those of you doing this for the first time. One says yes, one says no, and one says no opinion. And I would think that we're phrasing without being able to read the question. I'm guessing either yes means moon, no means more than moon, and no opinion means no opinion.
Yes, and I think it's actually raise your hand, meaning yes.
Oh, yeah.
And the question is, should this be to the moon only or include Mars? So to the moon only is yes, raise your hand. No, and no opinion, of course.
All right, we're going to leave this running for a little bit. Yes? I'm sorry? You... Thanks.
Sorry, the question is poorly formed.
Yeah.
Because it's not really yes or no.
So this is part of IETF lore. It always breaks down when it comes to making up these questions on the spot. I'm very sorry. It's not like we're new to this, unfortunately, Alvaro and I. But
so let's try it again.
Put a period where the comma is and ask the question.
I don't know if it's possible to edit the question after it's been posted, but yes means moon, no means more, and no opinion
Let's
means...
ask different. Let's ask, should the scope include Mars?
Yeah, that's good. Let's ask that. That's a much better question. We should have asked that for the first time. Anyway. All right. So new show of hands.
Lars, for every question you asked, what answer do you wish to record?
Right. No. I mean,
for the next question,
I would like to. Yeah, let's record the next question. This was a try run. Good job, everybody. We got some data. You managed to push the button. This one actually now matters more. And Gori, if you capture the numbers for the different options or a screenshot of whatever is the final count or something, that would be great.
And Lars, I think you should say it in the audio just to be sure.
I will. Yes. Okay, now should the scope include Mars? Yes / raise your hand means it should include Mars. No means it shouldn't include Mars. And no opinion means you have no opinion. Let's just run a little bit more. It's slowing down. I see 61 for yes, the scope should include Mars, 62 now. I see 34, no, the scope should not include Mars, and I see 9 undecided. So roughly 2/3, 1/3. Jörg?
Will you come to the time axis? I mean, you could include Mars in many ways, right? Later, after a recharter, or
right.
and so none of this has been put forward here.
Correct.
That might make people's choices different.
I think specifically, right, we discussed the charter as written at the moment focuses on the lunar deployment, but intends to keep Mars as an aspirational goal is the wrong word, but basically keep the Mars use case in mind to make it hopefully so that a solution for the moon will also be extensible towards Mars and beyond without too much extra work. No would have meant let's do like Moon only and not think about Mars while we're doing Moon. That's at least sort of how I thought we were going to answer this question. And probably I didn't understand it correctly. We're going to do a third hum, but that's at least sort of my hope. But thank you. The other questions we had planned are a little bit, and we're running out of time, are a little bit difficult to solve, but assuming we reflected the consensus of the working group in a charter, oh, there's too many ifs. Is there anything else you want to ask, Alvaro?
So I think we should ask who is willing.
Yeah, that's a good question. If we were to form a working group with a charter that made it past the ISG, we're going to use a show of hands again, like just to see who would be willing to actively work in that working group in terms of reviewing documents, writing documents, reviewing email, writing emails, so on. That is just for the area director to basically gauge whether there's just warm bodies in the room right now or whether there's actually people that are actually going to do the work.
Yes, so all the Lars says is who is willing to contribute? Yes, you are. No, you're not, or you don't know.
All right, that looks pretty good. 36 willing to contribute, 12 not willing to contribute, and 3 have no opinion. I'm pretty sad that you already know you're definitely not going to contribute, but that's okay. Is there any other question that we should be asking? I don't think so. Eric, as the AD, is there any other thing you want to say or ask at the microphone as people make their way to the door?
So maybe one more question, Eric Venk here. One more question. Is it the work to be done in the IETF?
Okay. Is the IETF the right place for this work?
Yeah.
Should this work be done at the IETF?
All right, the poll is open.
While it's done, I would love to thank you, chairs, all the speakers, and the room. I was concerned about getting some very controversial and controversy. There were controversy, but we stay polite, respectful. I learned a lot of things. So thank you. Oh, and by the way, we will need to do more work on the charter, obviously. We got all the feedbacks.
Yes.
And then we go.
So you can expect an email with a proposed charter text at some point soon. On the last hum, is the IETF the right place? 68 yes, 7 no, and 2 no opinions as of this moment. So that's pretty good. Thank you very much. Enjoy the rest of your day and your week. Yes. Okay, Warren reminds me to say that while we did a bunch of polls here, this is not the formal consensus establishment that will happen on the mailing list. So we're going to confirm sort of the sentiment we got from the participants in the meeting in the broader community, some of which might not have been able to participate because reasons. But it certainly already gives us some direction which way to go. Thank you.